Hello students, welcome to your next screencast. This one is about multiplying polynomials. That's right. Here we have a flower bed here, and we are designing a rectangular flower bed that you will border using brick pavers. These are the brick pavers right here that form the border. The width of the border around the bed will be the same on every side as shown. We have two parts to this question. Let's get to it. For part A, we need to write a polynomial that represents the total area of the flower bed and the border. All right, so let's do part A, and then based on that, we will continue with part B. So, we need to make a polynomial that represents the area of the flower bed and the border. Notice that it didn't say without the border or without the flower bed. It's pretty much everything. All right, now based on that, we are able to continue. One thing we know on this is that these little tiny widths right here of each of these brick pavers is x feet long. So that means just these two right here are x feet long and x feet wide? No, of course not. As it said in the problem, is that the width of the border around the bed will be the same on every side. So we also know that this little side right here is also x, and we also know that this little side right here is also x, and we also know that this side here, of course, is equal to this side, and this side here is equal to the length of this side because, as it said in the problem, it is a rectangular flower bed. So therefore, let's create a expression that represents the length first, because remember the area formula for a rectangle, length times width, also known as base times height sometimes. You can think of it that way. It all means really the same thing. So if we were to say that the width is, say, this side right here, well, we know this inner part right here is 6 feet long. But then that's not the entire length. We also have these two little x pavers also bordering it, thus creating to the length of that width. So therefore we have x, another 6 feet, and then another x feet. So we have an x foot here and an x foot here. So an x foot plus another x foot is 2x feet. So we know that's going to be part of it. The length is 2x. But then don't forget also to include the kind of the middle part, which is another 6 feet. That's not 6x, that's just 6, so 2x plus 6 represents the entire length. X plus 6 plus x simplifies to 2x plus 6. Using extremely similar logic, we know that this middle length right here of the flower bed is 5 feet, but then the pavers on the outside are x feet and x feet long. So once again, if we were to trace our finger across the length of the entire width, we would have x feet plus another 5 feet plus another x feet. So together, of course, another 2x plus 5. And there we have it. We have an expression that represents our length, 2x plus 6, and an expression that represents our width, 2x plus 5. Knowing that the area formula, reminding ourselves is length times width, we know to take the length, 2x plus 6, and multiply it by 2x plus 5. And we continue on from there by asking, how in the world do we actually multiply those two binomials together? Remember, a binomial, two terms. Well, we got to use that FOIL technique. That's right. So here we go. 2x times 2x, we know, of course, is 4x squared. Very good. You probably said that out loud. We know that 2x times 5, of course, is, that's right, 10x. Then we know the 6 times the 2, well, that's going to give us 12x, 6 times 2x. And then we know our final outside is 6 times 5, and we know that's going to be, of course, just 30. Now what we must not do, what we cannot do is we cannot leave it like this, because we always must simplify as much as possible and then put it into standard form, which means, another word is called descending order, which means the degrees of the polynomials must be going from greatest all the way down to least. So right now we look at this and we say, do we have any like terms? And it appears that we do. You see these two middle terms right here, 10x and 12x. Those can simplify together. 10 plus 12, let's see. Oh yes, that's 22x. And we don't have any other like term with this 4x or this positive 30, so simply bring them down. And because that 22x is positive, a plus sign must go in front and the 30 goes behind it. Now as we see here, 4x squared plus 22x plus 30, perfect. Now it's in descending order, aka standard form, and it's been simplified to its maximum. So we have actually completed A. We wrote a polynomial that represents the total area of the flower bed and the border. Well, almost. Don't forget, this is also in feet squared. So the area polynomial is 4x squared plus 22x plus 30 feet squared. And now for part B. Find the total area of the flower bed and border when the width of the border is 1.5 feet. Part B is asking us to find the total area of the flower bed and border when the width of the border is 1.5 feet. So what is the width of the border? Well, if this is the length of the border, then this little distance right here that was once called x, that is the width of the border. So therefore what they're saying is x is now 1.5 feet. So what we have to recognize is that this time we have to allow x to be 1.5, and that's what we're going to do. So wherever we see an x, we're going to replace it with 1.5 from our original polynomial that we just established all the way back in part A. So wherever we see an x, we're going to remove the x and remove the other x, and let's replace those with, of course, 1.5. And don't forget your parentheses around it to indicate that you are in fact multiplying and taking things to the second power. So we have to first continue, we have to simplify this. Alright, so how are we going to do that? Well, let's think about this. According to the proper order of operations, what do we do next? Well, let's take 1.5 squared next, and we know that of course is 2.25. And we're still multiplying that by 4, and we're still adding that to 22 multiplied by 1.5 plus 30, and we'll put our feet squared unit all the way at the very end, and then we'll confirm our work. So let's keep going. We know we're still using multiplication because we've already taken care of exponents. 4 multiplied by 2.25, feel free to confirm on your own, that gives me 9. 22 multiplied by 1.5, again, feel free to confirm on your own. That's 33. And then the 30 that I have not yet touched or done any other mathematics with simply brings down, and of course I am still adding them all together. So my final answer is going to be found once I add 9 plus 33 plus 30, which gives me a total of 72. And once again, don't forget your unit. I like to put it in at the end, 72 feet squared. So therefore what we have found is the area of the total flower bed and the brick pavers. Thus, once again concluding that we have our answer right here. We have found the total area of the flower bed and the border when the width of the border is 1.5 feet. The entire area is 72 feet squared. You know, that was just one way to solve it. Let me show you that you can also confirm your work, or heck, even do the work, another quick little way. You know, we could have easily just as solved this, again, by checking your work or by actually doing the work, by sending this 1.5, which was x, into its factored form as well. So wherever we saw an x back here, we remove those, and let's replace those with 1.5s. So let's see what we get here. Should we get the exact same 72 feet squared when we do it this way? Well, if we've done our math correctly, ideally we should. Remember, those are 1.5s. So, I mean, if we do it right, will we still get 72 feet squared? Well, let's simplify and find out. If we were to first simplify the length, which was once 2x plus 6, now 2 times 1.5 times 6, well, let's see here, 2 times 1.5 plus 6, feel free to once again to confirm that. We know it's just 9 because 2 times 1.5 is 3. 3 plus 6 is 9. And of course we're still multiplying that by whatever 2 times 1.5 plus 5 is. So 2 times 1.5, well that's 3 plus 5. So we're looking at 8. And look, we're still multiplying. And we know 9 times 8, of course, is 72. And again, 72 feet squared. So you'll notice that we still got the same answer using the the factored form of our polynomial versus the non-factored form of our polynomial. Thus, once again proving that if you do your math correctly, the factored form and the unfactored form are representing the same thing mathematically. So why do we factor it? Well, we'll learn in a few short classes that factoring it is the only way to solve for the x. Like, in other words, if 1.5 was not given to us and we had to solve what could x be, well, that's what we'd have to do. We'd have to factor it. So that, ladies and gentlemen, is your question that I will explain to you. Now for the one that I am asking to explain to me. Here it is. The designers of a new shopping center plan a sidewalk, a roadway, and a parking lot in a 500 by 800 foot area as shown at the right. 500 by 800 foot area. Find a polynomial for the area of the parking lot. Now this one is similar to what we just did, only not exactly the way we did it. Still got to use those powers of logic and deduction that we have been honing all year that you are so apt with, which I am so proud of you all for having. And also, please make sure that your final answer is in standard form. It will help. And for this one, hint, hint, if you're ever wondering which term should come before the other when you have degrees that are equal for two different terms, my suggestion is always go alphabetical. If you do your math correctly on this particular problem, you'll see what I mean. All right, good luck, everyone.